Now let us learn about diffraction of light, wave optics 10. In previous lessons we learned about reflection of light or refraction of light. Reflection was explained considering light traveling in a straight line, refraction also. And while studying Young's double slit experiment, we considered light as a wave. Now, interference. Now, diffraction is another phenomena, diffraction of light. And what it is, to explain diffraction, we shall consider light as a wave, or like this. And light waves, the wavelength of light wave, visible light, means from VIBGYOR, wave, from violet to red, the wavelength increases to this side, and it was roughly from 400 nanometer to 700 nanometer, right? Now, to explain this phenomena, we have to consider light as a wave, very small waves. Now, what it is? The phenomena of bending of light around corners. Bending of light around corners of an obstacle or an opening in the path of the light is called diffraction. Let me explain here in this figure, and I'll go to better figures in the next page. See, these are the light waves. If the source is at infinity, then these rays will be parallel. So when these light waves, and this black one, this is an obstacle, an opaque substance through which light cannot pass through, right? So since light cannot pass through this, the shadow of this point will be here, and the shadow of this part will be here. Means from this point to this point, let it be A, let it be B. So this is equal to A dash B dash. A dash B dash is not the image, it's the shadow. Means from A dash to B dash, this part will be completely dark. This part will be completely dark on a screen or a white wall. But due to this phenomena, the diffraction of light, these waves, light waves, as they approach this obstacle, these light waves at this sharp edge, here and here, if the edges are very sharp, they will bend. The light waves will bend. Means this bending of light at this corner and at this corner, if it is very sharp, this bending is called diffraction of light. So in the process, what is happening, if light was not bending, then from this point to this point would have been completely dark. Due to this bending, some amount of light arrives here, some amount of light arrives here. Means they encroach, means they spread into the geometrical shadow region. So due to bending of light, the shadow, which should have been completely dark, that is from A dash to B dash, is not completely dark. This part, there is some amount of light is falling here, that some amount of light is also falling here due to this bending phenomena. This bending phenomena is called diffraction of light. Now this effect is pronounced, means more visible, if the dimension of the obstacle or opening is comparable with the wavelength of light. Wavelength of light is very small. If the dimension of this obstacle is comparable with this, then this bending is more. So that I'm going to do in a different diagram. Now look at the diagram, another diagram. Now look here, this black portion is not an obstacle. There is a small opening here. This white part is a small opening. Plane waves are coming to this side. So since this is very small, Due to bending, this curved black curved lines are your diffracted waves, right? Now, this is a narrow opening or called a slit. Now here, this is not an opening, this is an obstacle. These are the light waves traveling to this side. At this surface and at this surface, the light bends. Look how it is bending. Look how it is bending. So, in normal situation, the shadow of this point should have been here, and the shadow of this point should have been here. But due to this phenomena, this bending of light around this corner and this corner, some light is spread into the geometrical shadow region. This is a screen. Now let us go to another diagram. Now look here, from this point to this point is an opening. From this point to this point, the distance is called A. Here I have reduced the distance from this point to this point. This white portion is also a narrow opening called A. Here, this white portion from here to here is also A. Going from this position to this position, this opening, this white portion from here to here, from here to here, from here to here is gradually decreasing. Here, the size of this opening A is very greater than the wavelength of the light, so there is no bending. Here, this opening, this white portion from here to here is comparable with the wavelength of light, so there is some bending of light due to diffraction. That phenomena is called diffraction. Here the opening is still less. If this opening is very less than lambda, then the diffraction means the bending is more. This bending is more as compared to this, and there is no bending here because this opening, the dimension is very greater than the lambda. The opening here is comparable with lambda. The opening here is very less than lambda. So if it is comparable with lambda or less than lambda, then there is bending of light, and the bending is more if the dimension, this opening, the slit width, the width of the slit is very less than lambda. This is called a diffraction, the bending of light around sharp corners.